So Copernicium, or Copernicium as the discoverers would prefer it to be pronounced, is the latest name to go up on the periodic table, and it's really very exciting. It's the first time for many years that a new name has appeared, and not only has it appeared, but quite excitingly, it's appeared with a bit of controversy. What should the symbol be? The first suggestion was that it should be called, this symbol should be CP, capital C with little p. And that's got really quite an argument. Inorganic chemists who use organic groups in their compounds got quite excited because CP is the symbol that's used for the cyclopentadienyl ion, which binds to all sorts of different metals. And then it was discovered or realized that many, many years ago, CP was used as an alternative symbol for element number 71, lutetium, which in some countries were called Cassiopeium. And I've looked in lots and lots of books that I've got at home, and I can't find one of them that uses this name. But the reason why it's important is because now more and more old papers, old books are being digitized on the internet. If you start searching for the symbol CP, it will start throwing up old papers and cause confusion. So the decision has been made by the International Union of Pure and Applied Chemistry or the recommendation is that the symbol should be CN, capital C, little n. And I think this is a very sensible suggestion because it is unlikely to be confused with cyanide, which is capital C, capital N. And it's also nice for our Chinese colleagues because CN is the domain name for Chinese websites. And I think most chemists will be very happy with that. The element itself was first made quite a few years ago, and it's made like all these heavy elements by taking the nuclei of two atoms that are lighter and banging them together. And if you're aiming for element 112, then you need to take two nuclei, which have atomic numbers, which when you add them together come up to 112. So in this case, you take lead, which is atomic number 82, and so to get from 82 to 112, you need to add 30. So you accelerate zinc atoms, which have atomic number of 30, towards these in a high-speed accelerator, and they every so often, and quite rarely, these two nuclei fuse together to give you an element or an atom of element 112. When you make the atom, it exists for a short time, which might be a thousandth of a second or a few thousandths of a second, or might be as long as half a second or even a second. And then the nucleus of the atom starts to decay. Now, it doesn't blow into parts just to protons and neutrons in one row, whoosh, but instead it starts going down by steps. Usually the atomic number changes by 2 units or 1 unit, depending what sort of particle is ejected from the nucleus. So in the case of 112, and I don't know the details yet, it will decay. For example, the first step might be go to 112, from 112 to 110. Then the second step might be just 1 unit to 109, and then 2 down to 107, and so on, until you get to an element below the mass of uranium, 92, which is stable.